The evolution in clinker cooling. The newly developed Claudius Peters EtaCooler, the most technologically advanced clinker cooler in the world today. The past decade has seen various developments and innovations in clinker cooler design. The cooler is one of the most important units. The 4-year EtaCooler development period demonstrates our effort to provide the industry with a well-engineered design. Strictly modular is one major principle of the new EtaCooler. The total cooler is built out of basic modules for a capacity range of up to 15,000 tons per day. Let's have a look at the design of the modules. The front end of the cooler is equipped with a static inlet, the high-efficiency HE module. It achieves an optimal clinker distribution over the width as well as the quick quenching of the clinker. The inclined, totally flat HE module extends from the kiln drop point to the transport lanes. It is aerated via independent zones. The slot plates are fastened by a single bolt. The transition from the static area to the movable lanes is accomplished by the first EtaCooler module with cross-sealing under the HE module. The moving, walking lanes require a unique seal design. The very special cross seal inside and between each lane has been designed to ensure that the cooler is totally riddling free. It uses a transport system that is unique to any of the present coolers, the walking floor system. The EtaCooler consists of parallel transport lanes which are moved together in the direction of the clinker transport and retracted individually or in groups. The individual cooler length and width for different clinker capacities will be built out of just 2 main module lengths. The width is variable by the number of lanes. Depending on the required throughput capacity, a corresponding number of parallel transport lanes are installed side by side, each supported on independent heavy-duty rollers. Independent lane movement, parallel, individually driven, aerated lanes. The slots for the air supply are integrated in the transport lane bottom by utilizing the Malden grate plate principle. The cooling air can penetrate over the entire bottom without any large dead areas. The EtaCooler has 1 or 2 hydraulic cylinder drive modules, depending on the capacity. Each lane drive is connected to one hydraulic unit, the power pack. The hydraulic cylinders with integrated continuous measuring system dedicated to each transport lane enable an adjustable long lane stroke. The speed of each lane can also be adjusted to the requirements. The last module of the cooler is the transition to the clinker crusher. This module is built out of the 2 standard units of different lengths. The active width of the crusher corresponds to the width of the EtaCooler. During the forward stroke, the lanes convey the clinker to the grizzly chute for screening the fine pieces and guiding the oversize directly to the crusher. Here we can see the HE module with special horseshoe castable design and integrated air cannon nozzles. Finally, the whole lane bottom is filled with clinker for heat protection. After all the years of development, all the hard work, everyone looked forward to this great moment. Clinker cooling has evolved. The next generation of clinker cooler is born. The new EtaCooler fits perfectly into the existing cooler building. The cooling fans are located in the basement on both sides. The hydraulic cylinders are connected directly to the power pack, which is placed on the burner platform. The cooler upper part was reconditioned and reused. The upper sidewall gives a view into the cooler through observation holes. The view into the cooler shows the unique movement of the clinker. For a clearer idea, here are some pictures of the test unit in the Claudius Peters Technical Centre. Forward stroke, 100% of the clinker moves forward. Backward stroke, only 20 to 25% is carried back. The higher transportability of the EtaCooler is not the only advantage. Even more valuable is the independent lane movement. The EtaCooler transport system actively influences the clinker conveying and distribution. For the first time in clinker cooler history, this virtually eliminates such problems as Red River. The hydraulic